Game Masters have a lot to keep track of. GMs control the environment, keep the story on track, improvise every NPC, control every monster, run puzzles ranging in difficulty from a 1st grade level to a 3rd grade level, or God forbid, a 4th grade level. So, if you're anything like me, taking anything off of your plate while running a game is a big help. And that's where this piece of advice comes in. And this might be annoying because this piece of advice is everywhere, oftentimes in a career context, and you might not want to hear this when thinking about your hobby, that's fine. But, the most surprisingly useful skill to learn as a GM running a game is coding. I know, hear me out. I have built myself a table rolling program for a wilderness survival arc where I just put in a player survival roll and it tells me whether the party stays on course, any random encounters they might come by, what the weather is, the terrain, any complications during those encounters, or if they decide to go hunting. I put in a survival roll and a stealth roll, and it tells me what kinds of creatures they encountered, which ones they successfully caught, and which ones got away based on those rolls and based on those creatures' rarities, or even stats that I might put in for those creatures. I wrote another program to run a large-scale war that was going on in the backdrop of a campaign I was running. It used random rolls to simulate battles and alliances and espionage and a bunch of stuff that I just wouldn't be able to manage manually while also running the game in the foreground. Letting a program manage the tables and the rolls and the calculations frees up my brain to focus on narration and managing the story. Now, learning to code is daunting and boring. And if you don't mind that, there are a million resources out there to learn step by step in great detail. But I'm just going to skip straight to the good stuff in this video and get you started on a project that is relevant to your interests. I assume. If you're watching this video to learn how to code and you don't play TTRPGs, you're welcome to stay, but you do confuse and scare me. By the end of this video, if you follow along, you will have your computer set up to run Python code, and you will have a simple program written to track initiative in Dungeons & Dragons, as well as managing HP and concentration. A couple quick points before we get started. One, I'm going to link the finished script in the description of this video in case you need to compare, but typing it up yourself from scratch as you follow along is the best way to learn, especially because I'm going to be moving fast, so it's probably better just to learn by doing, or else there might not be much learning at all. And number two, because this is a long video, it's going to be a lot less edited than the intro is, so just bear with me. I have a tic disorder, which I usually edit out, so just don't be surprised if it sounds like I'm sneezing a lot. So, with that out of the way, have fun, let's do this. All right then, so to start off, you're going to need to download Python. Python is the coding language that we are going to use for this project. It's pretty easy and beginner friendly. A lot of intro to coding classes will use Python. So you're going to want to go to the Python website. That's right here. And download Python. Just let it do the defaults on the download. If it asks you if you want to add it to your path, you probably want to say yes. That'll make the command line part that I show you in a second easier. And the other thing you're going to need is a text editor. So Python does come with one called idle. It looks like this. It's gross and I don't like it. The one that I like, that I recommend, is called Sublime Text. It looks like this. Or if you want to see, once we have some code, it'll look like this. And the last thing that you need for us to get going is to access your computer's command prompt, which if you're on Windows, you can just search command. It's this right here, command prompt. It'll start to look real cool and computery when you do stuff in here. If you're on Mac, it's called terminal, and it might work a little different. I'm not sure, I'm not an expert on Mac. But yeah, so once you're here, you've got your command prompt, you've got Python installed, and you've got a text editor ready to go. Let's set things up a little bit. Cool. That's really all we're going to need to get started. So now we're going to need to open a new document, right? So it'll by default be a blank document. Let's save as. And I'm just going to do mine on the desktop. You can do this anywhere. Let's call this Initiative Manager Demo. And the file type that we're going to want is .py, which is the sort of standard default for a Python script. So Initiative Manager Demo, select this, and then because there are a bunch of options for what a Python script could be, you're going to want to type the full file name here. We want to save this as Initiative Manager Demo.py. There we go. That'll save on the desktop. You can see I've got a bunch of other ones. These are my references. So we'll save that there. That's now saved on the desktop. And if you're in Sublime, it will have changed your formatting down here to Python. That'll just highlight some of the keywords and make it nice to look at. So now I'm going to have us write everyone's first script that any, intro to coding 1 video on YouTube will have you do this first. Everyone's first script is famously Hello World. And so all that this script that we're doing right now is going to do is print. Print is how we get things to show up when we're running the program. And we're going to print in quotes, because the quotes tells the script that we want this literal string of characters that we're about to type. Hello World. Because this is a D&D project, we'll make it a little bit more interesting, actually. Let's say, Hello Faerun. There we go. now there's some flavor to it. So now we're going to save our document. It's Control-S or save out of the menu. There we go. So that's all it does. It just says print Hello Faerun. Now, to run the script that we're writing here, you go into this command prompt, and first you have to navigate it to the location where this is saved. So you remember that I saved it on my desktop. The path to the desktop for me is C, that's the main drive of the computer, users:/OneDrive/desktop. And you can figure out generally where you are by just finding it in a file explorer like this. So the way that you navigate the command prompt there is with CD, that stands for Change Directories. And that's going to drill one deeper from the one that you're at. So you can see that my command prompt started at C/user/colon. I want to go to C/user/colon/OneDrive. So I'm going to do this. Start typing OneDrive, and I'm going to hit Tab, and it's going to autocomplete to the closest thing. If it autocompletes to something else, you can hit Tab multiple times, and it'll cycle through it. So CD to OneDrive, hit Enter, and now I'm in OneDrive. And then I'm going to CD to Desktop and hit Enter. Now you can see I'm working in the command prompt at C/user/colon/OneDrive/desktop. That's where this is saved. Great. So now our command prompt is navigated to the desktop. This script that prints Hello Faerun is saved to the desktop. Now we're going to make sure that we can access Python from our command prompt, okay? By default, with the Python installation, if you let it add itself to your path and let it do all the defaults, it should just be Python. And if you hit Enter, you should see that you've entered Python here, and you have these little 3 carets. And we're interacting with Python right now. We don't want to do that, actually, but that just shows you that it works. Some other things that it might be if Python isn't working, it might just be Py, which looks like both work for me. It might be Python 3. That one doesn't work for me. That actually goes to the Microsoft Store and asks if I want to install it there. So that's another way that you might be able to go about getting that installed. But find what works for you. You want to get it so that you get these sort of 3 carets there. And then to run our script, we are going to type Python, or whatever that keyword was, and a space, and then we're going to do the name of the .py script. So initiative manager demo.py. Just like before, you can start to type it. I want initiative manager demo.py. And you hit enter, and there you go. It prints Hello Faerun. So that is how you run a script. So now we're going to make our script a little bit more complex. We're going to start with it just rolling initiative for all your players, and showing you the initiative order. So let's delete this. And we're going to go over a couple of important sort of concepts in Python coding. To start with, I'm going to show you something called a dictionary. So to save information, you save it under a name, the name of a variable. Hi there, editing Colin here. I just realized that I sort of neglected to explain a very important concept called a variable. And I did intend this video to be sort of a very fast learn by doing sort of thing. But that being said, this part is very important and fundamental, so I thought it would be good to give just a little bit more detailed of a breakdown for anyone who doesn't necessarily already know what a variable is in programming or how to use one. So, a variable is a way to store information. You can call a variable whatever you want. For this example, let's say x. You assign it using an equal sign, so if I say x equals 1, x is now 1. If I ever check for a value using x, we get 1. And you can use that in an expression. So I could say, I could ask for x plus 3. That would give us 4, because x is storing the value 1. Now you can also reassign variables. So if we have x equals 1, and then later we say that x equals 3, then x is now 3. It's been reassigned. It's not 1 anymore. And an important thing to realize is that this right side is always evaluated before this left side. So we could now say that x equals x plus 4, and this x plus 4 will be evaluated first, meaning 3 plus 4, because x is 3. And so that'll evaluate to 7, and now if we ask for x, it'll be 7. Now, there are many kinds of information that can be stored in variables like this. There are integers, like we just saw, like 1. You could do a string, which is in quotes, which refers to like a word or a collection of letters and numbers that doesn't evaluate to an actual numerical value like that. There are things called booleans, which we'll see in a bit, which is just a true or false value. It's not the word true, it is the concept of being true. And there are many other things like lists you'll see. 2, 3, for example. This is a collection of 3 of these integers. There are a bunch of other things. You'll see dictionaries in just a second. But you can store any of these in a variable, and technically you could even change that. So you could say that x equals 1, and then you could say that x equals boo. And now x is equal to the word boo. So you can change types like that. At least in Python you can. Don't go trying this in a lot of other languages. You can't do this in Java, for example. But we're doing Python here. Python is very easy to work with, and this is one of the reasons. We're going to go over a couple of important sort of concepts in Python coding. To start with, I'm going to show you something called a dictionary. So, to save information, you save it under a name, the name of a variable. And a dictionary is a type of data that you can save. So we're going to save information about our first player. We're going to call this variable P1. And you assign the data to P1 with an equal sign. So P1 equals, to make a dictionary, we use curly braces. And inside the dictionary, you can associate keys and values of as much data as you want using colons separated by commas. And just like before, we use a string to tell the program that we use quotes to tell the program that we want a string, the literal sequence of characters that I'm typing, and not any sort of fancy code thing. So let's say for our player 1, we want our name, colon, to be Beanbag. That is the name of a character from my recent home game. So our name is Beanbag, comma, we'll add another thing to this dictionary. Our initiative, colon, is 2. We'll say that's the bonus that Beanbag gets when he rolls initiative. Close the curly braces. We now have a dictionary with some information about Beanbag saved to variable P1. So, let's make a bunch of players who are going to be involved in our combat. I'm going to copy that.
I'm going to paste it so that we have 5 of them. Let's make a P2, let's make a P3, 4, and 5. Our next name will be another player character. Toast was another character from my home game. We got Beanbag and Toast. Toast was a monk, high dexterity, initiative 5. Now let's do 3 monsters. Let's say we've got Goblin 1, Goblin 2, and we've got a Hobgoblin. Goblins have an initiative bonus of 2, so that's good. Hobgoblins have an initiative bonus of 1. So, that's our encounter. These are all the combatants. We have their names and their initiative bonuses saved. So that's the information that we need to roll our initiative, right? So, for ease of access later, I'm going to group all of these dictionaries together in what's called a list. A list is kind of like a dictionary, in that it's a collection of things, except it's not these key value pairs, it's just a bunch of objects saved in order. And we denote that with square brackets. So let's say that we're going to call it players. Players is going to be our list containing P1, P2, P3, P4, and P5. So now we have a list of all 5 players. Each of these P1, P2, P3, P4, P5 is a dictionary with all the information that we might need about that player. So now we're in a pretty good place to start rolling initiative. So let's talk about what it looks like to roll initiative. Now we're going to make something called a function. Just like we can save data to a variable, we can save a process to a function. So to show the program that we're about to define a function, the sort of keyword in Python is def, like that. You can see it highlights differently because we are going to make a function. Then we get to name it whatever we want. We're going to say this function is roll initiative. So we are about to define what the process means when we tell the script we want it to roll initiative. We open parentheses, and this for a function is where we give it the pieces of information we can provide to this process. So what rolls initiative? A player rolls initiative. So let's say we are going to pass in a player to this function. So this function is going to take in a player and give us back what our initiative roll was. That's the process. We put a colon to indicate that we are ready to start defining this process. Go ahead and go to a new line. If you're on a decent text editor, it should indent it for you. The contents of a function need to be indented underneath like this. Because that's how the program knows when it stops. It stops when it becomes unindented. So, to roll initiative, first we are going to need to figure out what the actual roll is. So let's say we're going to save another variable, roll equals, and now we need to do our calculation of simulating rolling a d20 and adding our initiative bonus, right? So we need a random number. So the next thing that I'm going to show you how to do is to import things. So there are a number of standard packages that come with Python. You can also get other ones, but we do not need to get that complex right now. We can use the built-in ones. There is built into Python a module called random. And random has a bunch of great resources and tools that you can use to get random numbers, choose random things from lists, etc., etc. But it won't have access to random unless we tell the script that we want to import that group of tools. So usually you do your imports at the top of the script. So I'll jump up into line 1, and importing it looks like this. Import random. And this is a good point to talk about the skill that makes up 90% of coding is Googling how to do something and then copying it or just taking tips from that. Because I didn't remember off the top of my head what the function was. I knew there was one, but what the built-in function was to get a random number. So all I did was Google search Python random number from 1 to 20. You can usually just search what you're trying to do. Anything with this Python logo is probably going to be the official documentation, which might be hard to read if you have never done it before, but it'll tell you what your options are of things to do. But a good resource usually is going to be Stack Overflow. Let's see, random number there we go. Random number generator from 0 to 20. That seems like it's pretty close to what we're looking for. And you can see, there we go. So from random import, and you can start to piece together what the things you need are. So the one that I found that was good is this one right here, randint. So after reading a little bit, I found randint, which is probably the best thing that we want. You can see that we need to import random, and then this person is saving as their random integer a method that comes out of the random library that we imported. The dot is how you know that it is like a child of it. So we want random.randint, which if we look up the documentation, we'll see that randint just takes what the first number and the last number is. So we're armed with how to use randint. So we're going to say roll equals random.randint number between 1 and 20. That's going to be our d20 roll. And then what we need to add to it, plus, is our player's initiative, right? So the way that you access one of these values from a dictionary is by doing what's called indexing out of it using square brackets. So I guess it's probably technically not indexing if it's a dictionary because it is a non-ordered collection, but that's beside the point. So we are going to take our player. We're going to use square brackets to access data from it. The data that we want is what we saved under initiative. So player brackets initiative is going to pull the initiative value out of whichever player is passed in right here. So our roll is going to be a random number from 1 to 20 plus the player's initiative. And then we have our roll saved. So now, so that we can see what's happening in our command line over here, let's print what happened. Print our player name plus use a plus sign to squish strings of characters that you want to print together. So our name plus space rolled space and plus and what our roll was. Now, the plus sign is good for squishing these strings together, like our name and the word rolled with spaces outside of it. But it might get mad at you because roll is a number, not a string, if you try to attach a string of characters to an integer value. So the way that we fix that is by doing something called casting. You don't super need to understand how this works. Just trust me, you need to do this. We're going to turn our integer of our roll into a string of the roll. So our strings can all get stitched together into one line of text. What we need to do for that is str, that is the system abbreviation for a string, and put that inside parentheses. So what we're adding to it is roll cast as a string. So it's our player name plus space rolled plus the string form of what our roll was. And the last thing we need to do in our function is give back what that roll value was. The word for that in a function is return. So this function takes in the player and it returns the roll. Great, that's rolling initiative. Now, all we need is to actually roll the initiative. Oops. So notice how I unindented because we're done working on our function there. So to roll our initiative, we're already going to print out what everyone's roll was. So we don't need to worry about like saving those numbers anywhere. We've got the numbers. All we want to do now is sort this list of players in order of biggest to lowest on what they would get if they were to roll initiative. So this is another thing that just Googling is great. I didn't remember how to do the list sort off the top of my head, but I Googled how to sort a list based on another function. And after looking at a couple Stack Overflow results, there was a pretty easy way to do so. So players, that's our list. And we found a method just with this dot right here. Just like there is random.randint, for a list, you can have list.sort. So our players dot sort. Sort by default will decide based on the system what it's going to determine to be greater than or less than other things, and it'll sort in ascending order. So the two things that we want to change is how it calculates what's bigger than another thing, because we want it to calculate that with roll initiative, and we want to change it to be descending order. So the first thing, and if you looked up this function, you would see that it takes in these options. Someone showing you how to do this on Stack Overflow would have this. Is we want to provide it with a key. The key is going to be our roll initiative. So the key is going to tell it how to sort them. And the order to sort them by default is ascending. But for the sort function to tell it that we want descending, we say reverse equals true. So what that's going to do is sort these in order. So if we want to see this working, let's go print players. So now it's going to import this, save this player information, put them in a list, define what it means to roll initiative, and sort the list based on their rolled initiative, and then print it. So if we were to run it again, we don't have to type Python initiative manager demo.py again. If you press up in your command prompt, it'll just do the last thing again. So that's nifty. And we hit enter. You'll see there's everyone's initiative that they rolled. And then there is the list of all these dictionaries in order from greatest to least initiative. It's a little deceptive there because it's showing the initiative bonuses and not the initiatives that they rolled. But all this list needs to remember at this point is the order it should be in. So you see Toast is first because Toast rolled a 24. Next would be the Hobgoblin. There's the Hobgoblin, and so on. But this is ugly and terrible to read. So let's print it a little bit nicer. So first, after it shows what everybody rolled, let's put an empty space into there to make it a little bit easier to see what's going on. For an empty space in our string, we use a special character, \n. \n means new line. This is short for a new line character. So that'll insert a blank line. Then let's print the string 1 for who's going first, space, close the string, plus. So remember we use, so we're getting a player out of the players list. Remember we use square brackets to access information from something, right? And we want what the first item is from the players list, because now they're in order. So the first item will be the first person to go. Now, in most cases in coding, counting is what's called zero indexed. So it doesn't count 1, 2, 3, 4, 5. It counts 0, 1, 2, 3, 4, 5. So the first item in our players list is going to be players index 0. Now remember, players index 0 is a dictionary, right? It's one of these. We can see it right here. This is players index 0. And we want to access their name. So we can do another square brackets to access their name. If we did that, we would see, there we go. 1 is Toast. Toast is first with the highest initiative of 23 in this case. So let's do this for all 5. Number 2, number 3, number 4, number 5. These are going to be index 0, 1, 2, 3, and 4. Save that. Let's run our script one more time. And there you go. It rolls initiative. It lists them in order. Hobgoblin got the highest at 21. Then it looks like Goblin 2. Yep, Goblin 2. Then Goblin 1. Goblin 1. Then Beanbag. And Toast at a 9. Oh, how far he has fallen. So that's the first step. That'll just roll initiative for you. That's probably not that helpful in a real game. But it will start to get useful once we add on more and more and more features. We're going to make this into something that you can actually use to sort of manage who's going as combat continues. So, the next thing that we're going to do is we're going to do two things before we put in those like little features to help you manage things that are going to make this a little bit better positioned to build off of. The first thing and simplest thing is we're going to add some simple tie breaking. So if we get, let's do this a couple times until we get some people that roll the same initiatives. There we go. So Beanbag and Toast both rolled 20. So we didn't put any way for it to break ties in here. So it's just going to leave things when it sorts here. When it sorts by their rolled initiative, it's going to leave them in the order that they were already in if they have the same value. So Beanbag came before Toast. Beanbag's going before Toast. Now, people have different ways that they like to break ties. Oops. A very common way is just who has the higher initiative bonus. Some people say to roll again. Easiest way for this is just going to be, say Toast goes first because Toast has a higher initiative bonus. And then if they have the same initiative bonus beyond that, you could do stuff yourself to add more tie breaking. I didn't care. I probably don't care enough to do so. So if they have the same initiative bonus and rolled the same number, I'm just going to let it go in the order that they were listed here. But Toast should be winning this tie. So what we're going to do is in our roll initiative, after we say what they rolled, the value that we return, I'm going to cheat a little bit. And I'm going to add to the roll 1/100th of their initiative bonus. So even though Toast rolled a 20, and that's what it shows, the value that it gives us back for Toast's initiative that it'll sort by will be 20.05. Because that means that Toast will have 20.05, Beanbag will have 20.02, and Toast's number will be technically higher. And that'll help us break the tie. So that's the easiest way that I decided on to break the tie. You could fiddle around with this, do it however you want, but I'm doing it by saying roll, plus our player's initiative over 100. So that'll break some ties. Let's see if I can get another tie. But that's a tie where they both have initiative bonus of 2. Can I get a tie between Toast or the Hobgoblin or something? 2 goblins. There we go. So now you'll see Toast and Goblin 1 rolled the same number, but Toast is going before Goblin 1 because Toast technically has an initiative of 7.05, and the Goblin technically has an initiative of 7.02. So there's our tie breaking. The other thing that we are going to want to do is get rid of this like manually set player list because it is going to make it annoying if they're just in a list like this. If another character enters the fray and we have P6 now, right? It would be nice if you could just copy paste P5, have P6, put in their important information and run the script. But then you'll have to go and we have P6 here and we need to print the 6th person. And that's a nightmare. You can't do that while you're playing D&D. You can't be editing so much of your code during a game. That will not be smooth or fun. So we are going to set this up to a thing you can imagine whenever you program is that if you have to do something very repetitively like this, you could probably do it more simply in a way that lets the program do the repetition for you. So what we're going to do is we are going to, first of all, we're not even going to save these under their separate variables here. We're just going to make our players list directly this without saving any of this. So we're going to delete all this. That's a nifty thing in Sublime text, by the way. If you highlight by clicking in your middle mouse button, like the scroll wheel, you can do like a select that doesn't go over lines. That's fun. But our players list is going to become this. So let's go players equals, remember a list is with square brackets, open the list, and we're going to close the list afterwards, like that. For ease of reading, let's indent that. I don't think you technically have to indent that, but it makes it a lot easier to look at. So our players start the list, this dictionary, this dictionary, this dictionary, this dictionary, close the list. Don't need this anymore. So our players list is now just these players. If you needed to add a new one now, you could very easily copy one, paste it, change the name, change the initiative. Easy. Hi, Colin from the future here. I forgot when I made this list that elements in lists need to be separated by commas, as we saw before. I forgot to add the commas. So these all need to have commas. So it is a dictionary, comma, another dictionary, comma, another dictionary, comma, until the last one. Now, that list will be sorted by the sort here when we roll our initiative. Now we don't want to print them all one by one. So now I'm going to introduce a new, very common and very important sort of structure of syntax of coding in Python, which is a for loop. The word for. So the syntax of a for loop is for blank in blank, and then a colon. So you're saying for each something in a collection of somethings, we want to do something. So we're going to say for I in, so we're using I as a shorthand for index because we want to know what number of the list we're on. We're not just going to say in players because we want to know what the turn number is that everyone's going on. If we just did for I in players, then I on each part of the loop would be one of these dictionaries. We want I to be the number of the portion of the list we're in so that we can point out who's on turn what. So instead of for I in players, we're going to do, and these are just two built-in functions that as you code more, you'll just build up more knowledge of what these are. If you, again, Googled how to do this simple thing, so print something for each item in a list or something like that, eventually you'd see someone doing it this way and you would just sort of remember. So we're going to combine two built-in functions. Firstly, we're going to use the range function. Range, when you pass in a number into range, gives you back a list of the numbers 0 through 1 less than that number. So because we have 5 items in players, that means that the indices that we can have in players are 0, 1, 2, 3, and 4. So range of 5 will give us a list of the numbers 0 through 4, which are then the indices of that list. I know that's a lot to wrap your head around. Just once this is built, you'll see how it works, and you can honestly just remember that it works. Understanding it is probably better, but you can also just remember that this is a very easy way, a very common way to build something. So for I in range, and to get that number 5, we don't just want to hard code it and write 5, because again, if we add a 6th player, that won't work anymore. We want to get the length of our players list. So we have a built-in function len, which gives you back the length of something. So len of players. So for I in the range of the length of players. So the length of players is 5. So the range of the length of players is the numbers 0 through 4. So for I in the numbers 0 through 4, colon, indent. And so now we decide what we want to do for each of those I's. So what we want to do is we want to print who's going at each position, right? So just like we were doing before, right? Let me pull one of these lines out from before. So our lines from before looked like this. We want to just mimic this. So to get a 1 from our index of 0, which is first, because 1 is how our brains work, 0 is how the computer works, the first thing that we'll want to print is I plus 1, right? So remember, we want to put it in a string so that we can combine it with other strings. We want I plus 1. We're going to print a string of I plus 1 plus another string, which is going to be dot space. And that covers this part. Plus, now we're going to do this again, right? But we are not just going to take 0 and hard code the numbers 0 through 4 like we did before. This is going to be I, right? I is going to be the numbers 0 through 4. We're going to do this 5 times. So the first time, we want player 0 name with a 1 here. Then I will be 1. This number will be 2. And we want player's 1 name. And it'll go through the whole list that way. Let's delete that. Let's still keep this extra line above it. And because it'll make it easier to look at later, let's put an extra line underneath it as well. So we're going to print an extra, a blank line. And then for each index in the length of players, we're going to print that index plus 1 and the player at that index's name. And then an extra line. Save that. Let's run it. Oops, what did I do? Oh, I forgot to put commas on these. All right, Colin from the present is going to go back to Colin in the past, and you will have already seen me correct that mistake. So, let's run it. And now we'll see, we get the same thing happening as before, but this is much more abstract and clean, and that's going to make our life a lot easier as we go forward. So, what do we want to do next? What I'd say we should do next is make it so that we can loop through this a bunch, one turn at a time. So instead of just showing you the initiative order once, it'll show you whose turn it is currently, and then you can like type next or something, and it'll tell you who's up after that. So now we're going to start to be interacting with our program over here. So what we're going to do is make another kind of loop. So this was a for loop. It does something once for each of something in a collection of things. What we're going to do now is called a while loop. While, like this. Instead of going through everything in a collection, a while loop repeats and repeats and repeats and repeats as long as a condition is met. So let's save a new variable called running. And we'll say that running is true. True and false with a capital T and F is a built-in data type called a Boolean. The only possible values of a Boolean are true or false. So while our condition is met, so while running, remember running is true. So this is currently saying while true, and it will stop running. This loop will stop going through itself when running becomes false. So while running is still true, we'll keep doing it. When running becomes false, this loop will end. So while running, we want to print whose turn it is, right? So we'll print. I'm going to add a bunch of blank lines at the beginning of this. You'll see it just becomes easier to keep track of in the command line when there's a lot of space between each turn, so that visually the turns don't get mixed together. So I'm going to add a bunch of new lines. Yeah, like that. So we're going to print a bunch of new lines. And our players. Now, we need to know what turn it is, right? So we're going to start with the turn being, we'll display it as 1 through 5, but it's going to be 0 through 4, right? And we need to keep track of what turn it is that we're printing. So before our while loop starts, let's make a new variable. We'll call it turn index. We'll set that equal to be 0 as a starting point. It'll always start with 0, the first item in the list. That's the person going first. We'll just have to remember during our loop, when it becomes the next turn, we'll bump that up by 1. And then we'll come back to the beginning of the loop, right? You'll see how that works in a minute. So we're going to print our players, which item? Our turn index item. We're going to, so remember that's still a dictionary, just like it's always been. So we're going to access their name. And then we're going to add to that the string apostrophe S turn. That's saying whose turn it is. Okay, so the first thing we're going to do in this loop that's going to repeat once every turn So we're going to print whose turn it is. And then we don't want it to just do that infinitely with no input, because you'll see that'll actually start to... It'll decide who's going first because we never incremented this. And then it'll just run forever if we do that because we never gave it a condition to stop in any way. See, if I run this, it'll roll, and whoever's first, it'll print their name 1,000,000 times. See, it's the Goblin 1's turn forever. If something's running, you need to just stop, by the way, at least on a PC. Control-C is our keyboard interrupt. So if you do that, you don't need to panic and be like, oh no, my computer's going to explode, catch fire, and burn down my house. It's fine. Control-C just tells it to stop. So we don't want it to be the Goblin's turn forever. So we want it to print this once and then wait for our input. There's a built-in function called input. When the input function is called, it will wait for us to provide information in the command line. So you can see there's our turn order. It's Toast's turn, and now it's waiting for me to say something. Now, what I say here comes back in our input variable. So let me keyboard interrupt that. So I want to save what it is that we type here into that input. We're going to have a bunch of options once we build out a lot of features here. So I'm just going to save that as the command. So whatever I type there is going to be saved into the variable command. It'll be saved as a string, one of these quote things. So we get our command. Now, first thing we should do is have a way to stop the program. So this will go infinitely unless you Control-C it. Let's just have a way to stop first. So first, let's say if command is equal to quit. And by the way, this is going to be a double equal sign. So a single equal sign is for assigning a variable. A double equal sign is for checking if something is equal. So if command equals quit, colon, this, by the way, is an if statement. It's, I think, pretty self-explanatory. That's one of the ways that some coding, and especially Python, is pretty okay considering like natural language, in that what do you want to do? Well, if command is quit, you just literally type that. So if command is quit, let's print bye-bye. And then we will set running to false. Remember, running is how we are keeping this loop going. So running will become false. It will stop looping. Right, so let's try that. Goblin 2's turn. It's waiting for my input. If I type quit, program ends, says bye-bye. Great. To make sure that it's easy to come back to later, let's keep track of what our available commands are. So we're going to leave what's called a comment. If you do a number sign, anything after a number sign is not included in the code. The computer will entirely skip that. So you can put whatever you want here and it won't mess it up. So let's comment that quits the program. Great. So now we want to add another command that we can have, which is to go to the next turn. So let's say for that we can do n or next. So we can type the word next, or because we'll be doing it a lot as a shortcut, let's accept n as well. So this will do next turn. Let's add that. So we have if command equals quit, we stop. We could just go straight into another if statement, but it's a little bit more efficient if your next if statement is like mutually exclusive from the last one. So the command will not be quit and next because those are different words. It's more efficient if you say elif. That's short for else if. So if command is quit, do this. Else, so otherwise, if your command is not quit, if command is equal to n, or is an operator that just lets you have multiple conditions. Nice and easy. Or command is equal to next. So if our command is equal to n, or if our command is equal to next. Then what we're going to do is increment our turn index by 1, and allow the loop to continue again, right? So we're going to say that our turn index is equal to turn index. Sorry, I didn't need to do that. Well, I'm going to need it in parentheses. You'll see why. Turn index plus 1. So our turn index will go up once, and we'll do the whole loop again. We're going to have a problem eventually. You'll see how that works. So it's Beanbag's turn. If I say N, it becomes Toast's turn, right? We'll see Goblin 1, Goblin 2, then Hobgoblin next. If I type next, it's Goblin 1's turn, Goblin 2's turn, Hobgoblin's turn. But if we try it one more time, we get an error because we're only incrementing this up, right? So we got the first item, the second item, third item, fourth item, fifth item, and then it's asking for the sixth item. There's not a sixth item, so we get an error. So we're going to do a neat little trick using an arithmetic operation called modulus. So we all know our addition, subtraction, multiplication, division. There's also something called a modulus. So modulus, what it gives you back is the remainder if the two numbers have been divided. So like 12 divided by 5, doing like integer division, is 2, right? You can put 2 5s into 12, but there's 2 left over. 2's the remainder. So 12 divided by 5 is 2, remainder 2, right? Modulus just gives you that remainder, 2. So you can use modulus to keep increasing your increment, but always have it be less than what the number was. So if we have our turn index increase by 1, but say that we want that turn index to then be modulus, we use a percent sign for modulus. Modulus, the length of the players list. Then our turn index is going to increment by 1. And if it becomes more than if it becomes more than or equal to the length of players, which is 5, then you can, imagine the division increasing, right? So this is 5. If we had, 1 divided by 5 for the first one, no remainder. 2 divided by 5, 1 divided by 5 is 0, remainder 1. 2 divided by 5 is 2, remainder 2, or 0, remainder 2. 3 divided by 5 is 0, remainder 3, then 0, remainder 4. 5 divided by 5 is 1, remainder 0. So once turn index gets to 5, which is the 6th item, this modulus will make it become actually 0. If we put 7 in here, it would be 7 modulus 5, which is 2. So that will make this number, instead of increasing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 forever, it'll make it go 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Because we're looking for the remainder if it were divided by 5. So, a lot of math that I brought in, I know. You can just remember that this is a neat little trick and move on. And generally, I think if you just keep following along and doing what I'm doing, you don't have to understand all of it, but you'll pick up some tricks. And the more little projects like this that you start to try to build, your brain will start to just figure out how this works. So that's how we're going to stop it from exploding once we get past it. So let's run our program again. Goblin 1's turn, Goblin 2's turn, Hobgoblin's turn, Toast's turn, Beanbag's turn, and then we should be going to the top of the initiative order with Goblin 1, 2, Hobgoblin, Toast, Beanbag, Goblin 1, Goblin 2, Hobgoblin, Toast, Beanbag, etc. And we can quit. So, one last thing that we want to add in as a command here before we start adding more functionality is what happens if you type in something that is not one of our commands. Right now, it does nothing, right? It doesn't meet this condition or this condition, so it just does nothing, goes back up to the loop, right? So if I do that, it's just Beanbag's turn again. So we want to add some indication that what you typed in was not valid. So let's add one more thing here. We have if, we have else if, and finally let's add else. Else means if none of the previous if conditions were met, do this. So if our command is anything other than quit, n, or next, let's print what? And then let it continue again. So this will just be our little indication that it got something unrecognized, right? So we can go through the turns. If I ham-fisted the keyboard, it'll say, what? So we have sort of a catch-all case there. So, great. Now it's tracking one turn at a time. Awesome. Now, that's useful, I guess, but it's probably better to know a little bit of context. So let's start adding, when it says whose turn it is, let's add who's on deck as well. Let's add, a little preview of what the next couple turns are going to be. So our little print here of whose turn it is, we want to add also who's next and who's going after that, because that'll make it a little bit more useful. So we're printing whose turn it is. Let's then also print 5 spaces to indent it underneath. And let's have it say next. And we're going to use the modulus again. So players is our players list. So we want to access the index from players of our turn index plus 1. And then we're going to want to do the same little modulus trick there to make sure that that plus 1 never goes above 4, right? So actually, we can just pull this directly, because we're going to do the exact same thing. Turn index plus 1, modulus the length of the players. So that is our, remember, getting an item from the players list gives us a dictionary. Then we want to access that dictionary's name. So this line is going to print a little indentation and next. And then from the list of players, it will get the dictionary of the one that is the turn after this and print their name. Right? So let's save that. What did I do this time? Oh, I forgot the plus sign. Oopsie. Okay, so we're printing that string plus, my bad, because we need to combine those strings just like we did up here. Next, plus that element for our players. So now it says Beanbag's turn. Next is Toast. And as we go through some turns, when we get to the bottom of the list, you can see Goblin 2's turn and Hobgoblin. Once it's Hobgoblin's turn, Beanbag will be next because we did that modulus. Hobgoblin's turn, next is Beanbag. One thing of personal taste, I don't love it when the important information is all the way at the left-hand side of the command line like this. I like it to be indented a little bit so it stands out. So what I'm going to do here is after all these new lines, I'm going to add a 5-space indentation. I'm going to make this indentation 10 spaces. So that everything is indented a little bit more nicely. There we go. And so my commands are all the way at the border and the results are here. Great. Now let's add who is going after this. Copy this whole line and print. Then turn index plus 2. Run it again. There we go. So now it tells us that it's Toast's turn. Goblin 2's up next. Beanbag's going to be after that. If I say N, then that'll cycle through. It's Goblin 2's turn. Beanbag's next. Goblin 1 after that. So that we have a little preview of who's coming up. Great. One more thing that I want to add is that it's good practice to make it so that your program can still run if you do something that's unexpected that you fail to account for in any of your code. Because it would be a pain if you accidentally messed up some edge case somewhere and you do something that causes one of those errors that just stops execution. But you've been tracking your combat the whole time. You need to remember, whose turn it is, whatever. We're going to add other stuff like HP tracking and stuff later. You don't want to lose all that. it'll be a pain to get caught back up if you need to restart the program. So to make it so that you don't have to restart the program if something's wrong, we're going to add another keyword here. Just like we have these like paired keywords in if and else, there are paired keywords called try and except. So in our while running loop, we don't just want to do this, because if there's an error, we don't want it to stop. We want it to try to do this. Just like this. Try. Want to try this. If it can't do this, if an error happens somewhere, we want to tell it what to do so that it can handle that error and keep running. So the paired keyword with try is except. So if it could not do what it tried, then just like with our else statement above, we will print what? I can't really demonstrate this working because I can't think of a way that this would break. But while I was designing all this ahead of time, I did accidentally break it at some point, and I was like, when I was working on the HP stuff, and I was like, oh man, I lost all the adjustments I made to everyone's HP. So it's good to do this because that means that your program will keep running no matter what. You're not going to lose any of the values that have been saved. Okay, great. Pretty good script so far. So speaking of HP, let's make this more interesting. So now it's giving us the turns in order. It's starting to get functional and usable, but it's not really doing much for us that we couldn't very easily do by just looking at a list on paper, right? And I mean, at the end of the day, this isn't going to do stuff that we couldn't do on paper because it's a pen and paper game. It's possible to play on paper. But the point of this is to give you less to think about during combat when you're running it, right? So it's giving you a little bit less to worry about because you don't have to look on your paper and look at this and go, okay, who just went? Goblin 2 just went, so it's Beanbag's turn. Instead, you can just press N and it'll tell you exactly whose turn it is. Okay, so it's removing a quarter of a second of thinking right now, but let's build that up by giving it more features. So we're going to make it so that our initiative tracker can also be used to track the HP of our monsters, or of all the characters, but the players will be keeping track of their own HP. You can keep track of it here too if you want. If you want to just keep in the back of your mind what everyone's HP is, that can be good. If you want to be, fudging your encounters a little bit for tension. But ultimately, the important thing here would be for your monsters so that you know like when they're dying and stuff. So let's add some HP tracking. So let's go back up to our player information because now we need more information about each of these players. We not only need their name and their initiative, we're going to need their max HP, and we're going to need to keep track of their current HP, which we'll be adjusting as things change. So by the initiative there, we're going to have another thing, which is called max HP. For Beanbag, I'm saying this is like a low-level encounter, but he's a barbarian, so he has a lot of hit points. Let's give him 25 hit points. And as things start, he'll be at full health, so his current HP will also be 25. All right, let's add this same stuff to everybody. Toast. It's a little squishier. Let's give him 15 HP. Goblins have 7 HP by default. Now, 7, on a monster stat block, how it says it's 7 or it gives you a way to roll their HP. If you wanted to use this this method of rolling down here to roll the monster's HP, you could probably build something to do that. I'm not going to do that, but that would be interesting so that you could have everyone's HP be kind of variable but not have to roll their HP at the start of combat. That would be nifty. I'm just going to do 7 though, and it's 11 for a hobgoblin. Okay. We have everyone's max HP and their current HP. We have to save their current HP with it because we're going to be modifying that as we go, and we need to be able to keep referencing that. So, we have that. Great. Now, let's have a new command that we can have. This command is going to be HP. You could split this up into like heal and damage or something if you want. But I'm just going to do the command of HP, which adjusts HP. So I'll give it a negative number if I want to do damage. I'll give it a positive number if I want to heal. So I'll say, HP minus 7 if I want to be dealing 7 damage to something. Let's format that. So if it just typed in HP as the command, that wouldn't help because I need to tell it who's taking the damage and how much damage they're taking. So we're going to make it so that we can have more complex commands. So let's say that we will format this command as HP space the name of the entity that we are changing the HP of space the amount that we want to change their HP by. So we're going to be passing in 3 words, right? The word HP, and then a word that is the name that we're adjusting, and a word that is the amount. So that's going to make it so that it's going to be a little different, because to identify that our command is HP, right? So let's add a elif command is equal to HP. To identify that our command is HP, the command won't be HP. The first word of the command will be HP. We need to split up the command by the spaces, right? So we need to know not just what the command is, but we need to know what the first word, the second word, and so on is. So we're going to use another built-in function here that applies to strings, these things in quotes, called split. So input gives us a string of what we typed in. We're going to take that string, and we're going to say dot split. And when you split a string, you tell it what character you want to split it on, and it gives you a list in order of the substrings that are connected by that. So we're going to split it on a space. I'll show you what that looks like. Nope. If I go into our Python interpreter here, let's say that we have a string called s that is equal to I have dark vision. That's 3 words, right? Connected by spaces. If I say s dot split, and we split it on spaces, it gives us a list that is I, have, and dark vision. That's exactly what we want, right? Because if our command was HP beanbag -4, right? If that was our command, then com.split on spaces gives us the first word being HP, and we also have beanbag and -4. So command is now going to be a list, not a string. And the important thing for these commands is what the first element is. So we're going to access index 0 of the list for all of these. Great. So now we're saying, else if the first word of the command is HP. Now we are cooking. Okay. What are we going to do if the first word of the command is HP? Well, first we need to access the player that is at the index at command 1, right? So command index 1 is going to be the name of the player, right? Like that. Now, looking up the index in a list of the dictionary in it based on the value of one of the things, so the value of the name, is a little bit too complicated for it to be like a built-in common function that there's a shortcut for. So we're going to need to design a way to do that. So we're going to add another function here at the beginning in our functions that are defining these processes we can use later on. Let's make a process here. There's a function called def player index lookup. This is going to be a function that we can use to, when given a player list, a when given a player list and a key and a value, it's going to give us the index in that player list that our player's dictionary is. Right? Because if we're dealing 4 damage to Beanbag, what we want to be able to say is give us the index in the player list of the dictionary for which the name is Beanbag. So we need our player list, and we need the key, which we'll be passing in name, and the value, which we'll be passing in Beanbag. Right? What we're going to do is we're going to do a for loop like we did before. We're going to loop through each index in our player list, and we're going to check if it is the case that we have that key value pair. Okay? So we're going to say for I in, and this is how I said you'd just start to get used to this over time. It's very common. Range len, just like we did before, the len of our player list. So our player list, in this case, what we're going to pass in, it's going to have 5 things. So range len 5 is going to give us the numbers 0 through 4. So I being each possible index in players, right? For that, what we're going to want to do is first, we need to know that the key we're passing in is even in there. We're only going to give it valid things, but it's good to do this check anyway, so that we don't get errors if we tried to look up something that's not in there. So we'll say if key is in is a keyword that gives you true or false whether the thing in front of it is inside of the thing after it. So if key is in player list I, so player list I is going to be whichever dictionary we're checking. If key is in that dictionary dot keys. Keys is a function that is built into dictionaries that gives you a list of all of the keys. The keys are the things in front of the colons. So the keys of this are name, initiative, max HP, and current HP. So if key is in player list dot keys and player list I, now we're going to access that key because we determined that the key does indeed exist. So if our player list I, which is a dictionary, key, passing in the key to look up, in this case, key is name, right? So if this is the case where I is 0 and key is name, then we're saying player list 0's name. So player list 0's name, which will give us back Beanbag. If player list I key is equal to value, right? So we're seeing if we have that particular key value pair, then we'll return I. I is the index of that item. So if we're looking up toast, for example, then we're going to check if first we're going to check if player list 0 name is toast. Player list 0 name is Beanbag. That's not toast. We won't return I. Player list 1 name is toast. Toast matches toast. This is true. This whole thing evaluates to true. Yes. So we'll return I, which in this case was 1. So we have the index of of which player we are targeting here. And then it's good to have still a return value for if you failed to find what you're looking for. So if you go through this whole for loop and don't find what you're looking for, we will return none. None is a built-in value that is nothing. So we can check later when we call this, we can check if the result is none, we do something because we failed and we need to handle the error. But we should be getting back the index, assuming we're doing a valid lookup. Now, one thing that I'm just going to add to make this a little bit easier, because it would be a pain if you typed in Beanbag with a lowercase b and then it didn't match because technically there's a different character at the beginning. I'm going to do this match, not just matching, Beanbag for Beanbag. I'm going to convert them both to all uppercase characters first so that capitalization doesn't matter. I'm going to do that by saying dot upper and dot upper. What dot upper does is, so remember we have that string save down here of I have dark vision. S.upper makes it uppercase, so that if we make it all uppercase first, the capitalization of what you're searching won't matter. Great, so we have our player index lookup. That'll make our lives a lot easier down here. Okay, so if command is HP, first thing we need to do is find the index of the person we're targeting. We'll say P_IDX. That's what we'll call it. That's what our player index is going to be. Is equal to player index lookup. That's the function that we just defined. And we're going to pass into it our list of players. We're going to pass into it name is the key that we want. And the name that we will be searching for is command 1, the second word of our command. So command 0 is going to be HP. Command 1 will be the name of the person that we're hitting. And then command 2, we'll access in a minute, is going to be the amount that we need to adjust their HP by. Okay, so we have our player index. So we need to make sure to account for the case that, that the name you type in, that you misspelled it, that you typed in Gorblin1, right? Or Coblin1, that's me. In which case, it would fail to find what it's looking up, and it'll return none, right? Because none of these have a name of Coblin or Gorblin or whatever, right? So before we go any further, let's say if PIDX, which is the value returned when we called that a minute ago, is equal to none, we will do our usual thing and print what? Which will be sort of our prompt to try again. But else, that means assuming we got back a valid index, we need to go adjust that player's hit points, right? So players access item P index. That's why we looked at P index, right? So that's going to be the item in players of the character that we're adjusting this for. Players P index. We want their current HP. So this is a bit of a more complicated assignment than we've been doing. So we've been doing a lot of assigning values to just the name of a variable. We can also assign to existing variables, right? Like we did with running here, right? So you can take an existing variable that we already declared up here and assign it a new value. This is more complicated, but that's just exactly what we're doing. We're saying inside of our players list, inside of the item at our player index, inside of its current HP, so we're currently pointing at one of these numbers, we're just going to reassign it to a new number. Our new current HP is going to be equal to what it was, so our previous current HP. And you can reference itself in the assignment. So the way that it calculates this is it calculates everything here and then puts it here. So you can reference itself because it won't have changed yet. So our player's current HP is going to be equal to our player's current HP plus command 2. Now, one little tricky thing is that this actually technically isn't going to work because even though it looks like a number, this number is in fact a string. We can't do math with it. You can remember if you look down here, the way that it split this up, it's in quotes, right? That is not the integer value -4. That is just the keyboard strokes, the string, dash, and a 4. So just like we had to convert numbers into strings when we were printing them before, we're going to do the opposite here. We're going to convert this string into a number. Specifically, we're going to convert it into an integer. So just like str is our shorthand for a string, int is our shorthand for an integer. So we're going to turn command 2 into an integer and add it to their current HP. And then we will print some spaces to make it nice. And we'll print their name. So from players, our players P index name and a colon space and their current HP. So let's just copy this whole thing because this is what we're going to be using to access stuff for the players. So plus their current HP. And remember, that's going to be a number, so let's turn it into a string. So their name, colon space, their current HP plus a slash plus, let's grab this again, because we want to say it's that, out of their max HP. Great. Let's give that a shot. So if we run this again, so we can cycle through turns, as we always have been, let's hit our Hobgoblin for 5 damage. HP of Hobgoblin minus 5. So now it'll print. That Hobgoblin is now at 6 out of 11. One little problem that we have that we need to correct for is that currently we don't have any bounds on what we can do with this. We can say HP Hobgoblin, we're going to add to it. Don't use a plus sign, by the way, for a positive number. It'll get mad at you. So if we're adding, just type the number. So if we want to heal it by 100, uh-oh, it'll let us. We're at 106 out of 11. Similarly, if we wanted to say that we were going to add to it minus 200, let's just go to negative 94. So we want to bound our HP to 0 and our max HP, right? So let's jump back here. And let's do one little thing to that current HP calculation. So our current HP, once we calculate it and get that number that's like 106 or negative 94 or whatever, we want to get the the greatest between that number and 0, and we would want to get the smallest between that number and max HP. So we have built-in functions called min and max for this. So if we do the min of that, or copy this again to access stuff, the min of this, which is our calculated number, or our max HP. So it's equal to the minimum value between what we calculated or our max HP. So we'll never get a number above our max HP. And we also want to put this inside of a max. So we want the biggest number out of that whole thing that we just calculated, or 0. All right, so that whole calculation that we did, we put it inside a min function with a comma space our max HP. And then we put that whole thing inside of a max function with a comma and a 0. So the smallest number we can get is 0. The biggest number we can get is our max HP. And we'll only get their current HP if it's in between that. Let's run it again. So if I say toast, oops, HP, oh, and remember, capitalization doesn't matter, so I can do this if I want, right? Because that's why we did the upper thing. HP of toast minus 5. You see toast is at 10 out of 15. If we do it again and say minus 50, toast goes down to 0, because in 5th edition D&D, you cannot have negative hit points. Great. Now, let's heal toast by 55. He's at full HP. Actually, let's, for demonstration's sake, be a little bit under full HP. And let's heal him for 5. You can see his HP does not go above the maximum. Now, it can sometimes go over the maximum if you have temporary HP. I'm not going to do that, but if you have like a bunch of warlocks in your party or something, and you get a lot of temporary HP, and you want to add a command in here for like temporary HP, more power to you. Go for it. But I'm not going to do that. So, great. We can manage, we can manage HP now. So the next thing that I want to be adding for us, we're going to add 2 things next. One is the option for a character to die when they hit 0 hit points. But before that, just because it's a little simpler, I want to add a check command. because now that we're starting to change people's hit points, I want to be able to see everyone's hit points. I don't want to have to deal damage to someone to see how much HP they have. So let's add a new command here. I say elif command 0 is equal to check. Check will be the way that we see what everyone's hit points are. So let's add to our list of commands here that check is going to display the current status of our combatants. And I say current status because we're going to be adding even more fun stuff in here later. So if we do check, what we're going to do is we're just going to go through all of our players in our player list and print what their current HP total is, right? Pretty simple. So remember we did that with a for loop. We don't need to be accessing the index here right now because we don't need to know like what everyone's position in the order is. We just want to show everyone. So we don't have to be doing that I out of range len thing. We can just do for P in players. So for P in players, each P is a dictionary, right? Players is a list of dictionaries. We will print some spaces to make it nice, plus P's name, plus a colon and a space, plus the string form of our current HP. So string of P current HP plus a slash plus the string form of that player's max HP. And it's just going to do that for everyone. Nice and easy. Save that. Let's run our program. If I type check, there we go. We get that. Shows us everybody's HP. Nice and clean. Okay. Now, and just so we can see, let's do HP toast -5. Oops. See, this is why it's good to put error handling in, because I accidentally put a space there. So our third item is not a number, it's just a dash. So for sure that threw a disgusting error, and I think our try except there caught that and printed what for us. So great. Fix that. HP toast -5. Toast is now 10 out of 15. And if we check, we can see those HP values. I'm going to add some other things that show in here. One thing I'm not going to add, but I'll leave as an exercise to you because it would be pretty simple, is with the bloodied condition coming back in the new 2024 rules for D&D. If you wanted to like add an exclamation point to the end of this, if they're below half health, or print a little message when they take the damage if their health becomes below half, you could totally do that. I think that would be cool. That would be fun. Or add another line that says, if this is below half, toast is bloodied, or something like that. That sounds like a terrible breakfast. But yeah, that would be fun. I'm not going to do that right now. I'll leave that as an exercise to you if you want. If you want in this HP thing to add like another if underneath the else and say that like if the current HP is less than the max HP over 2 to print another message or something. I think that would be cool. I'm not going to do that. So we added checking. Now we want to add the ability to die. So I don't want to just immediately remove someone from the initiative order if their HP hits 0, because if you use it to track a player character, then they'll be sitting on 0 making death saves. If it's an important villain, you might do death saves as well. Or even if you meant to do -5 HP and you accidentally did -50, you don't want them to just disappear and then lose the tracking on them, right? It might be nice to add a way to add a combatant back in mid-combat. That would be a cool function. I'm not doing that. Not right now. But I will make it so that if their HP hits 0, it asks you, would you like to remove them from combat? Because if Goblin 2 hits 0 HP, I'm going to say, yeah, just remove it from the initiative order. We don't care about it anymore. Or I could say no, leave it in, but, I'll just know to skip its turn because it has 0 hit points or something. But I want that option. So, in our HP removal, after we change our current HP and print what their HP has become, I want to do some more things. What I want to do is say if, I'm going to copy this whole thing again so we can access things. If our player's p-index current HP I could say equals 0 because we already capped it so that it can't hit 0. In case I missed something, which I know I didn't because I've already tested this, but in case I missed something and it's possible for the HP to become negative, we don't want it to behave weirdly. So probably a better thing is to say if their HP is less than or equal to 0. This is how you do less than or equal to. Similarly, that's greater than or equal to, right? If their HP is less than or equal to 0, then I want to print a little prompt to ask if we want to remove them from the initiative order. So we'll print remove space plus our player's name plus space from initiative order. And I will only do this if I say Y for yes. So I'll say Y to confirm. So I'll print that. And after I've printed that, I'm going to ask for input again. And I'm going to save the input that we get in a variable called confirm. Confirm is going to be the input that I asked for there. So I'm going to say that if confirm, and I'm going to do the same upper trick to make sure that you can type a lowercase y or an uppercase y. If confirm.upper is equal to uppercase y, then I will print their name and is no more. And then we need to remove them from our players list because now we are deleting them. We're erasing them. They are no more. So there are a couple ways to remove an item from a list. Since we have their index in the list already, that's probably we'll just remove it by index. So there's a function for that for list players.pop. You pop something out of the list. So we'll remove, we will pop our item that is at p index. Let's give this a shot. Let's quit and run it again. Oops. Did I forget a plus sign again? I did. Plus. Hee hee. So we'll run it again. Let's deal some damage to people. Let's kill goblin number 1. So let's say HP goblin 1 minus 10. They have 7 hit points, took 10 damage. You see they're at 0 out of 7 now. Would I like to remove them from the initiative order? Y to confirm. So if I do anything other than Y, like an N for no, it will not remove them from the order. You see they're still in the order there if we want goblin number 1 to be rolling death saves because we really like goblin number 1 and we want our party to save and adopt them or something. If we did want to remove them, because this death thing happens whenever they take damage and it checks it at 0, we can just hit him for more damage to run that check again. Let's deal 10 more damage to him. And it asks if we want to remove him from the initiative order. If we type Y, goblin 1 is no more. And if we check our combatants, goblin number 1 is no longer there. Yay! We have added death. Now, fitting that I messed up typing goblin a second ago, and it took me longer than it needed to, because that would be a pain while you're trying to run combat, and goblin number 2 now gets hit for 5 damage, and you're like HP goblin goblin 2 minus 4. You don't want to get held up like that. So let's add the ability to do some abbreviations to make our lives a little bit easier. So let's go up into our player info and let's save another piece of information about all of these things. Let's save an abbreviation. Our abbreviation for beanbag will be BB. And let's save one of these for everybody. Our abbreviation for toast will be TST. Our abbreviation for goblin 1 will be gob1. Goblin 2 will be gob2. And our hobgoblin will be hob. Great. How do we make it that we can, in our HP command, search for their proper name or their abbreviation? Well, where is it that we do that search against that name? It's in our player index lookup function, right? So we're going to beef up our player index lookup so that we could give it an actual name or our abbreviation. So for each of these items in the list that we're going through, the first thing we do is we check if we have that exact key value pair, right? And then if we do, we return our result. But let's do one more check. So after our if that, let's also check if our key is named specifically, then we want to check the abbreviation as well. So if the key value pair that we're looking up is a name, it's not that we're like looking it up by their initiative number or something, which I think everything we're doing here, we're going to be looking up by name anyway. But if the key we're looking up is name, and the value we passed in is equal to player list I, or like we were doing player list I, right? That's how we access the dictionary we need. If the value we're looking for is equal to, instead of our player list I name, it's our player list I abbreviation, then we want that to make us return I as well. So we were already checking if we have this key value pair. Now we're checking if the key is name and the value is that dictionary's abbreviation, then we also want to return I. So that will make it so that we can run this again and we can say HP hob minus 4. And that'll be a much faster way instead of typing out hobgoblin. Great. One more step to make our life easier. Now I'm going to do one more thing for this little version of this program. I invite you to, maybe explore writing some very simple programs yourself to get used to coding, and then add your own stuff to this. Like I said, maybe you want to add bloodied. Maybe you want the a command to add temporary HP because you have a lot of necromancy wizards and warlocks and stuff. Maybe you want a command to add a new combatant. There are a bunch of things. So you could definitely add more stuff to this. The last thing that I'm going to add is concentration. So I'm going to go down here. I'm going to add a new command that we can do. This command is going to be conc. That's going to toggle, or it toggles concentration. And we're going to format this as const, and it is our name or abbreviation. Because remember, when we do a lookup, we can take the abbreviation now. So actually, I'll also put this here, or abbreviation. So if our command is, let's add a new command. Command 0 is conc Okay, so we're going to need to be changing something about our player again, much like we were doing with HP. So let's go add a new, a couple of new things to our characters up here. The first thing that we're going to add is whether they're currently concentrating on something. This is going to be a value that we edit, just like with current HP, right? So we're going to add our const, which for everyone is going to by default be false. And then another thing that I'm going to handle in here with the concentration is everyone's constitution saves to see if they hold concentration. So false. And we will also keep track of their con save. Which, as I've mentioned, Beanbag is a barbarian. So he's going to have a con save of 6. And then we're going to take these and give them to everyone else. So everyone's concentration is going to be false to start. Toast is going to have a con save of 2. Goblins have a con save of 0. Hobgoblins have a con save of 1. Great. Now we're keeping track of that. So if our command is const, we're going to, just like in HP, first thing we need to do, because we're editing things in those dictionaries, is look up our command 1 argument to get the index of the player that was specified in our command, right? So we have our p index now. And then we're going to also do the same thing as HP and say that if p index is none, and we gave an invalid player name, we'll say what? Okay. Else. Just like with the current HP, we're going to do a little reassignment, but we're just toggling it. We don't need to do a calculation, right? So players, p index, their const is going to be equal to the opposite of whatever it was previously, right? So there is a nifty little keyword in Python, not, that just negates any true or false value after it. So everyone's concentration starts as false. I'm just going to say that their concentration is equal to not what their concentration was. It'll just flip it. Okay, so if I run our program again, I should now be able to say that Goblin 1 is now concentrating. All right, but there's no way to see this in our program yet. So the way that I'm going to check if someone's concentrating is with the check feature. So let me go back into our check command here. And I want to put an asterisk in front of them when I check them if they're concentrating on something. That's how I'll know that they're concentrating. So let's, before I print, save a concentration string, which will by default be an empty space. And that is going to replace this space right here. So that'll be a space going in this space. But if they're concentrating, I want that to be an asterisk, right? So we have our concentration string there. Then before we print, I'm just going to say if p concentrate const and I don't have to say if p const equals true, because p const is a true or false value. So I can just say if p const, then const string is going to be equal to an asterisk instead of a space. So if we're not concentrating, it's going to stay as a space. If we are concentrating, it's going to become an asterisk. Now I'm just going to stick it in here. I'm going to delete one space and say plus const string. So now instead of 5 spaces, it'll print 4 spaces and our const string, which is a 5th space if we're not concentrating, an asterisk if we are. Great. Let's run our program again. Let's say that Toast is concentrating on something now. And let's check our status. There we go. We got an asterisk on Toast showing concentration. If we also gave concentration to Goblin 1, then when we check, there's that. And remember, it just toggles it. So if we wanted to get rid of toast concentration, then const tst will do the trick. If we check now, toast is not concentrating. Great. Now, the last final little thing that I'm going to show you how to do is we're going to add into our HP adjustment the constitution save that you do to maintain concentration when you take damage. Now, up to you if you want to add sort of like a little prompt for confirmation, like we did with death, in case you're tracking your player's HP on here, but you want your player to roll their concentration save on the table so that you can say, don't adjust it here. Or if you have something like I think there's a feat that lets you roll your concentration saves at advantage or something. You might want to code something like that in. All up to you. I'm just going to keep this simple and just have it roll your concentration save when you take damage. So, I'm going to go down here, and at the same indentation level as our check of if the player's current HP is less than or equal to 0, I'm going to add elif, the integer form of, remember, command 2 is our third item, which is the damage that's being done. So, or rather, our HP adjustment. So if the integer form of our HP adjustment is less than 0, so if we're taking damage, and our player is currently concentrating, so players, I'm just gonna grab one of these, and our player's p-index const. And remember, we don't have to say equals true because this is already a true-false value. So if our HP adjustment is negative and the player is concentrating, then our player's p-index concentration is going to be equal to, and now would be a good time to, just like we did with rolling initiative, let's define a function for what it means to roll a con save, or roll a concentration check, rather. So let's go up into this little helper function area, and let's add one more. It's going to be pretty similar to roll initiative, right? Because we're still going to do a d20 plus stuff. So let's take this as sort of a template. But instead of roll initiative, we're going to have this one be called roll for concentration. Rolling for concentration, we need to pass in a player so we can get what their con save information is. We also need to know how much damage was dealt to them. So we're going to get a roll, just like we normally do. A roll is going to be a random number from 1 to 20. But instead of adding our initiative, we're going to add our player con save. Then we can print what they rolled if we want. But I think it'll be more interesting to just say their roll once we've determined the result. I'm gonna get rid of this. Actually, I'm gonna get rid of both of these because now we're gonna start doing something else. I guess really the only thing that we need to take over here was that roll line. Okay. So once we've rolled our con save, one of two things could happen, right? Either we hold on to the concentration or we drop it. So the condition for holding our concentration is if our roll is greater than or equal to, and the rule is whatever number's bigger between 10 or half the damage, right? So our max of 10 or damage over 2. But remember, damage, it's not really damage, it's an HP adjustment, right? So it's coming in as a negative number. So actually, to make it even clearer, let me say ADJ for adjustment, right? So it's our adjustment over 2, but we want the max of 10 and the positive version of the damage. So let's divide it by -2 so we can swap it over. So if our HP adjustment is -6, then -6 divided by -2 is going to be our positive half damage number of 3, right? So the biggest between 10 and our adjustment over -2. If our roll is greater than or equal to that, we will print our... We're going to format it like this. So our player name plus held onto their concentration. Yay. And then let's put their roll after this in parentheses. So let's put a single parenthesis plus string form of roll plus a close parenthesis. And then we want to return a value because we want to know where from what we were doing down below. We want to know whether or not we succeeded or not, because we're going to have to start changing values based on whether we succeeded on the save. So let's return let's return true if we succeed on the save. Oops. Oopsie. Let's return true if we succeed on the save. Else, so if any other condition besides succeeding on the save, which, because this is like a binary choice, means failing on the save, let's print a similar thing, but let's change the language. So then we will print player name dropped concentration, and we'll include their role in that, and return false. Great. Now we have a method, or a function rather, to roll for concentration. Let's go back down to our HP adjustment. Okay. So what we're doing was, if our HP adjustment is negative and our player was concentrating, then our player's new concentration value should be equal to roll for concentration, passing in player's p-index, because remember, player's p-index is that player dictionary. That's what we needed in that other function. Roll for concentration of player's p-index and the integer form of command 2, because that is our HP adjustment. Great. So if we have taken damage and we're concentrating, our concentration value is going to become the true or false value that comes back from this function that we just defined, and this function will print stuff for us of what's happening. The last thing that needs to happen with concentration is that also, if a player drops to 0 HP, they're going to drop concentration with no roll, right? So let's, before this print, let's add one line to just say that, let's get one of these so we can access stuff. Our player's p-index concentration is going to become false no matter what it was before if we've hit 0 hit points. Okay. With that, I think that should handle everything that we need to handle concentration. Do you want to try this again? So let's give Toast concentration. We check. Toast is concentrating. Now let's hit Toast for some damage. If I say HP for Toast minus 5, Toast gets hit for 5 damage. So half of 5 rounded down per D&D rules is going to be 2. And so the greatest of 10 and 2 is 10. So Toast will be making a Constitution saving throw against a DC of 10, right? That's just the D&D game rules. So if I do that, you can see there we go. Toast Constitution save was 13. Toast held on to their concentration. If we check, Toast is still concentrating. If you took that damage again, ooh, a 22. I believe that's a nat 20. If you wanted to add in stuff for nat 20s, that would also be a fun adjustment to make. But Toast has a con save of 2, and with a total of 22, that's a nat 20. Nice job, Toast. Let's heal up Toast so we can keep damaging him. Give him 10 HP back. You'll see, because we checked for the damage being a negative adjustment, he doesn't roll for healing. So that's great. But let's hit him again. Great con saves, Toast. Great con saves, Toast. Let's hit him again. Oh, well, if we hit him again, he'll go down to 0 HP. You'll see, now it's asking me if I want to kill him. I'll say no, but because it's at 0 HP, he's dropped concentration. Let's give him some HP back and make him concentrate again. So there we go. We're concentrating. Let's hit him for 1 more damage. Concentration check against 10. Damn, still succeeding. Okay, Toast, go off. Uh-oh, there we go. I believe that is a natural 1. What a way to go out, Toast. Toast dropped concentration that time. If we check, Toast is no longer concentrating. So there we go. That is all I'm going to be walking us through building today. This is, I think, a useful little tool now. You could run a combat out of this, track all your monsters' HP. It'll tell you when they die. You can use it to keep track of your concentration on everybody. And I invite you to make adjustments to this. I know looking at it now, it might look overwhelming if this is your first coding project. If I delete this blank spot, it's exactly 100 lines long. Sick. But, hopefully having gone through this slowly, everything here makes sense. If you want to, in case you need to come back to this later, leave some comments for yourself, specifying what everything is. Maybe space things out a little bit more so that all of your commands are very separated. You could do that. So it's clear, like, here's our HP section, whatever. We already put comments for our commands there, but if we want to specify, like, right here, that what this does is, player is a dictionary, ADJ is the HP adjustment, ADJ is negative for damage, and returns true if concentration is held, false if dropped. So you can add some comments like this to your stuff to make it a little bit easier to go back to and look at things. Because as someone who codes, I definitely try to leave a lot of comments in my stuff, because as someone who codes at my job, if you code something and then don't work on it because it's done and you just use it, and then 2 months later you're like, oh man, we switched to D&D 2024 and like I want to keep track of the bloodied condition in here. Let me go make some adjustments to this. It is annoying to then go back and be like, oh man, what does all this mean? Oh, this is so dense. What does it all mean? And having a lot of comments explaining exactly what's happening really helps with that. So if there were parts of this that like you followed no problem, were very easy, you don't think you need notes for, like, don't note anything there. But if you built this out along with me and you were kind of getting what was happening and you think you might go in and make your own adjustments to it later, like, maybe as an exercise, go add some comments to it, describing what all these little sections are, what they do, so that if you need to come back to it later, you know what everything is, and you know where to add things, so that, like, if you have these sections very cleanly spaced out with maybe comments saying what they are, I don't feel the need to put comments here because the first line is asking what the command is, so it's clear what this section is, but but then you would know, like, I need to handle the bloody condition in the HP adjustment section, and you would be able to find, there's our HP adjustment. I know that this is what I need to edit. And I also need to edit our check section to be able to show that, and let's make this a little bit more distinct. So definitely go in, tweak this to make it look nice to you and in a way that is easy to read to you, as easy as it can be. I know it can be hard to read, and is as well documented as you want it to be. And yeah, welcome to coding. Just coded a nice little 100-line project that you could totally run while playing D&D. You could have your stuff up here. Let's get some stat blocks. You can be running your game from your computer like many people do, have a bunch of tabs open with monsters and stuff, and just have this little command prompt here that you are running your initiative order from. And while you're DMing, you can say, all right, the hobgoblin's going to go. Near what they do. Goblin's turn. Beanbag, it's your turn. What do? You could run it from this nice little tool. And I invite you to maybe just look up on the internet other little coding projects. Get used to it. You get used to it pretty fast. I built a whole, like, super long... let me see if I can find it. I built a whole super long, right here, complicated table roller thing for a, like, wilderness survival section of my last campaign. I guess it's not actually that long compared to actually long things. It's like 300 lines long. But this handled all of the resource gathering and hunting and traveling to see if people get lost and simulating the weather and doing, rolling for encounters, whether it's going to be a big encounter, a small encounter, or an encounter with a special monster that's hunting them. Because I thought it would be fun for all that stuff to be randomized in a very random game like D&D, but it would take so long whenever they're deciding that they want to move on through the wilderness or hunt or gather or whatever. It takes so long to, like, roll on a bunch of tables. So I built this table roller. And there are a million other things you could build to just be little tools that you can just keep up in a little command prompt window right here. Interact with it with that input command. Yeah. So I pass this knowledge off to you. May you make good use of it. And roll well, my friends.